So we're continuing the discussion on the density pressure chapter. This should be the last class for this discussion, and we'll solve some problem after we discuss this part. Today's topic is hydraulics. How does hydraulics work? One of the misfortunate thing about your syllabus is that the entire principle that governs the whole hydraulics mechanism is operated by Pascal's law. Was a scientist. He did extensive research on liquid and gas pressures. Unfortunately, that Pascal's law is for some reason is not included in your syllabus. But to make sense with you for the hydraulics chapter, I'm gonna state that law and bring you up for the understanding for how hydraulics work. The key idea for hydraulics is that if we have some fluid within a closed system, listen to the words very carefully. If we have some fluid means liquid or gas. If we have some fluid within a closed system means that fluid is trapped by within a certain encapsulament. If a fluid is if a fluid if a fluid kept within a closed system is applied pressure on a certain portion of it, the pressure that force creates gets equally distributed across the entire fluid over all area, which basically means that if we apply some pressure on a certain closed amount of fluid, the pressure that we're going to create is going to be same everywhere, which brings us to a very advantageous idea for how we can increase the force. The core idea for hydraulics is that what you can see over here, that in this figure, if you have a look over here, that we have a closed system of liquid. The reason we are preferring to use a liquid, because unlike gas, liquids are typically incompressible. The reason liquids are incompressible, because you have to understand the atomic or molecular structure for solid liquid gas. The key difference between solid liquid gas can be summarized like that. There are actually a lot of differences, but the part that is important for our discussion, and I'm stating that part, is that solids are something like the particles are pretty much stuck in a fixed position. The only motion that they can achieve is vibration. They can vibrate about their position back and forth, and that vibration can be pretty fast. And that's how solid particles can have some energy within themselves. So that's, if we cool down a solid object, the particles are going to vibrate less. Now, vibrate less can mean two things. It can either mean that the frequency of vibration decreases, so there are less number of back and forth motion or oscillation, that's the word. There are less number of oscillation per second, that's frequency. Or it can also happen that the particles might lose their amplitude, which means that they're not going to move as far for every oscillation. They're going to move less. They're going to cover less distance, or they're going to have less displacement, or in other terms, they're going to have less amplitude of motion. And for most cases, both of these are affected. But these are the two things that can be affected whenever we cool down a certain solid. But the particles are pretty much stuck in the same position. This is why solid objects do not experience Pascal's law, because the particles cannot flow around. Whereas in liquid and gas, which we in generally call fluid, the particles are not attached with each other. They don't have a fixed position within the body. They can move around. But the state of liquid is something like that you pretty much have within a liquid. The molecules of the liquid are pretty much in contact with each other. They're touching each other. They're in contact with each other, and they're touching each other. But they are not essentially fixed with them. They are not essentially stuck with each other, which means if you push down, they're going to move around. One of the ways that you can visualize this for a physical world can be somewhat like if you think for very dry sand. If you push your finger through sand, then the sand is going to move around, and it is going to allow your full hand to go through. Although sand is a solid object, but it has a visible similarity towards liquid. Sand is not a liquid. Sand is still a solid where the particles are loosely attached with each other. But within every sand particle is a solid object. But multiple different grains of sand, they are loosely attached to each other. So that's the physical comparison that I'm trying to get in your head, that within the liquid, every molecule are that kind of detached. They're touching each other, So the intermolecular space is pretty much similar as for a solid, but they are not essentially bonded with each other. They can freely move around. That enables a liquid to move out on one place if some other place is pushed down. So they're going to and they are pretty much incompressible. The reason they're incompressible because the molecules are actually touching each other on their sides. So if we apply some force on a certain part, practically the in between space cannot be reduced, because the particles have to become physically distorted or compressed. Molecules are going to have to be physically compressed to do that, which usually is a very tough thing to achieve. It's not impossible, but it's very tough to achieve. So that's why we say that liquids are almost incompressible. The reason we use the term almost, because under extreme pressure we can also do some measurable amount of compression of liquids, but that is significantly less. That is way too much smaller compared to the amount of compression that would be seen for a gas substance. Within a gaseous substance, the particles are actually completely detached from each other. They can move around each other pretty easily, and there are large amount of intermolecular space. Average intermolecular space is pretty large, which means if we have some amount of gas closed within a system, and if we apply pressure on one side, before the gas particles actually transfer that pressure across the whole thing, they are going to preferably reduce their intermolecular space to compensate for that reduced volume. So they're going to get closer. The average intermolecular space will become closer, so they are highly compressible. So by applying even a little amount of force, we can do significant amount of volume reduction for gases. This is why within a system of hydraulics, gaseous substance is not very much preferred, because we would want the force to be multiplied, and that can be only achieved effectively if we use a liquid. That liquid could be anything. It could be any liquid that you can name for. Any liquid or every liquid will work for this. But for usefulness purposes, we preferably don't use water, because water itself is not corrosive, but water, whenever it comes in contact with iron, gives rise to rust. So that's a problematic thing that we don't want to have. Uh, and most of our metallic equipments, which are supposed to be very strong and sturdy and be able to withstand huge amount of stress and deformation force, they are technically made from iron, because iron is a pretty available ore within earth crust, and it's pretty strong. So it's cheap. Basically it's cheap, and it's abundantly available. So that's why we preferably don't use water. But if we use water, we can do that. We can also achieve a hydraulic system for it. But using water within a hydraulic system, we should not. The basic idea is that we shouldn't use iron and water side by side. If you want to use a hydraulic system that will use water, you better choose some other material which will not react with water. You might be using aluminum, you might be using copper, or you can also choose to use some sort of very strong plastic, but preferably not iron. And for iron-based cylinder piston mechanisms, or iron-made structures, which are the most strong ones, we prefer to use some sort of oil. They can be mineral oil, they can be some other form of oil. Oil actually doesn't cause any rusting, to be honest. While oil actually coats the surface of a metal, so that atmospheric air or humidity cannot actually reach to the metal surface. It actually gives a very thin film of coating over the thing, which basically elongates the longevity of the equipment, so it can be used for a pretty prolonged time without much replacement or repair. So that's why we preferably don't use water. But then again, whenever this whole thing was developed, whenever this whole thing was the whole idea of hydraulics was actually developed, scientists were mostly using water, and then later they find out that the corrosion is a problem, so so the industrial people, they opted to go for oil. So that's why we still use our term hydraulics. Hydro basically means water, but technically we don't use water for most of our practical hydraulics purposes. And if we have some gas molecules, or if we have some gas bubbles within a hydraulic system that is basically filled up with water, but if we have some sort of gas, then we are going to run into some pretty severe problem. I'm going to discuss about those problems after a while. So here comes the figure. All of you can see this. What is shown over here is that uh, whenever we have two cylinders over here, these are the side views of the cylinders. We are basically seeing a long section of the whole apparatus. This is a thin cylinder, and this is a thick cylinder, so which means this is a smaller cross section area. Has a larger cross sectional area, and these two cylinders are connected by a connecting tube, and this whole thing is filled up with liquid. Let's say some sort of oil, and there is no gas bubble, or there is no presence of gas within this system. So if we apply F1 force onto this smaller piston, this is going to produce some pressure over here, and that pressure can be calculated as F1 by A1. Pressure is given by force by area, so that pressure is going to be available over here. This pressure would be equally applied across the entire wall of the cylinder, across the entire inside wall of this pipe, and all over this thing, which means if pressure is developed over here, that pressure would be working all over the connected liquid body, and that equal pressure will be also be affecting on the bottom of this large piston as well. You have to understand that this is the cylinder, and the thing that is keeping the liquid in a closed system is the piston. So whenever this pressure is going to work upon a larger area, we are going to have a very large amount of force. So what you can see over here, because pressure is same everywhere within the liquid, for that's the basic idea for hydraulic system based upon Pascal's law, not within a syllabus. We can write P1 equals to P2, which means whatever the pressure we get under piston 1 is going to be the same pressure we're going to get under piston 2. And from, if you write the definitive equation for pressure F1 by A1 equals to F2 by A2. So F2 by F1 equals to A2 by A1. So if we subject the F2, we get F2 equals to A2 by A1 into F1. This is the interesting equation that is going to be mostly helpful for us. If you have difficulty remember this one, you just remember this thing, that within a hydraulic system pressure should be equal. If you can remember this one, you can always derive this equation to your convenience, no big deal. What is interesting for this equation is that you can see that F2 is equal to the ratio of A2 by A1 multiplied by F1. So F2 is going to be this times bigger compared to F1. This is a certain number, and you can see over here that the way we have designed this whole system is that we are applying a small pressure over here, and we're getting a larger pressure over here, because here the area is large and here the area is small. So if it so happens that, let's say, A2 has 10 times the area, cross-sectional area of the piston A1, then the ratio of this to A2 by A1 is going to be what? 10, which means by applying F1 force, you're going to obtain 10 times force on the F2 part. So if you apply 1 Newton over here, you're going to get 10 Newton. If you apply 10 Newton over here, you're going to get 100 Newton. If you apply 5 Newton over here, you're going to get 50 Newton. So that's how much force are you going to get out of this whole system is entirely dependent upon what is the ratio between the large cylinder, large piston and the small piston. This process or this mechanism of multiplying force is basically what we define as hydraulics. This mechanism is actually very useful because it can help us to achieve large amount of force while applying a very small amount of force, which means that stuffs which wouldn't be normally normally be recommended to for doing to be done by a single person, we can essentially use a hydraulic system by applying a smaller amount of force, which our basic regular person could do, and we could actually multiply this whole force. This is basically how every hydraulic jacks work. uh, so this is the basic idea. And then here we have some information that hydraulic systems must not have any air or gas bubbles in it. If there is bubble, when F1 is applied, the high pressure causes the gas bubble to compress to its smallest possible volume first, and then piston 2 is pushed above. So which means that if we have some gas bubble within the system anywhere, the moment we're going to apply this force, that gas bubble is going to start to become smaller first. So you might be applying pretty a significant amount of force, and you'll see that this piston is going down. But as long as that gas bubble is not fully compressed, you will not see any movement of this piston 2. Piston 2 would pretty much remain in the same position, which means basically you have to push this thing a very large amount to be able to see any available force over here, because once the gas is compressed to its smallest volume, that's only when this force would start to work onto this F2 part. And so that's the basic idea. It says, the last line, it says that this makes the system slow responding and energy wasting. Then the next point we have, we could increase force. Do you think the more work is done on piston 2? So this is another question that we have to think about. Here you can see that by applying a smaller force, we are getting a larger amount of force. So, and we also know that the equation for the work done is given by force into distance covered, which means if we do, let's say, 10 joule of work by pushing this piston, are we gonna get more than 10 joule over here because we just increased the force? And the answer is a solid no, because energy is a conserved quantity. You have learned about this thing, that the conservation of law of energy and work, they are pretty much the synonymous thing. Energy is energy, and work is another version of energy. If we do work on an object, it gains energy. If an object has some energy within itself, it can do some work. So it's basically pretty much the same thing. It just have on two different names depending upon how we look at it. However, the point is, uh, if we have the question, the thing is says that we could is more work is going to be done on piston 2. Now here's the thing that you have to understand, that whenever we are going to push this piston down, this piston is going to push down and it's going to remove some amount of volume of fluid from cylinder 1. Let's say before the push, let's say before pushing, the amount of oil within this small cylinder was, let's say, 10 liters, and the amount of oil within this large cylinder was, let's say, 100 liters, let's say. Now if I push it down by a volume of 5 liter or let's say 5000 cc, cc means cubic centimeter. If you push it down by 5 liter, it means from this cylinder through this tube 5 liter of oil would be going out, which means 5 liter oil will be coming up over here. The amount of volume decrease from cylinder 1 oil should be exactly equal to the amount of volume increase for the cylinder 2. You cannot have more volume over here compared to the reduction of volume of oil over here. That's not going to happen because we are working with physical objects. We're not creating objects, we're just moving them from one place to another place. This is what this equation is about. It says that delta V1 equals to delta V2. Now, if we write this whole thing in terms of the cross-sectional area, the cross-sectional area for any cylindrical object can be given by the cross. So the volume of any cylindrical object can be given by the cross-sectional area into the length. So if you want to think about this, let me just take this picture out and do some drawing maybe. Okay, I cannot copy this whole, so let's just use snipping tool. And here comes the whiteboard. I just connected my. Okay, I have magnified this to a very high value so that we can all see it very conveniently. So what I'm trying to tell you is that, let's say if this cylinder goes down by a certain depth of, let's say, D1, and the cross section area being A1, so the amount of liquid that is actually moved out, let's say this whole volume of liquid, I want you to visualize this liquid by a small cylinder. Maybe this liquid can be represented by a cross sectional area of A and a cylindrical volume of oil which has a height of D1. So let's say the cylinder 1 is going down by D1 and the cross-sectional area is A1. So the total volume of this whole oil is V1 equals to, I can write in delta V1 because this is a change of the volume. It can be written as A1 into D1. That's the amount of oil that moved out. In the same way, the volume that of oil that got into this cylinder in terms of V delta V2, change of volume of oil for cylinder 2, can be given as A2 into D2, which means these two things, these are the numerical values by geometric formula, solid geometry formula for the amount of volume, for the amount of oil. So if we now equate these two equations, interesting things are going to happen. Have a look over here. You can see that whenever we're going to equate in this thing, A1 D1 equals to D2, this gives us that D1 by D2 equals to A2 by A1. That's just rearranging the whole equation in terms of with the similar type of quantities on both sides. And we saw a bit earlier by the law of hydraulics, or by Pascal's law, we saw that A2 by A1 is given by F2 by F1. So we just brought this ratio from the earlier discussion. And now if we cross multiply these two, so D1 multiplied with F1 and F2 multiplied by D2, we get F1 D1 equals to F2 D2, which means the amount of work done that was done within the cylinder is exactly equal to the amount of work obtained over here. Considering there is no loss, you are going to do the same amount of work. But essentially the amount of height rise over here should be very small. You have to understand that if this area amount of oil actually enters over here, this is going to become pretty flat out, which means, let's say, this thing is going to go up by a very small amount. I cannot actually, okay, I cannot actually do this very well over here, but let me just show you this thing with maybe a perspective here. Maybe this amount of oil, whenever it's spread across a larger surface area, larger cross section area, might have a very small height. So in this case, maybe this one is your D1, sorry, D2. So the product of this much, I mean, this is not I, this is the length information, length arrow. So A2 D2 is equals to A1 D1. So if you use that equation, you can see that the product of force 1 into D1 is always equals to force 2 into D2, which means we are not actually increasing the amount of work done, which is impossible to happen. So we are working the same, we're doing the same amount of work. So we are basically gaining a larger force at the cost of a smaller distance. So you might wonder that, well, fine, we got this thing, but what if we need to move this object pretty high above? Because if you think about it, let's say, if you think for a hydraulic jack that is used to lift up cars or vehicles or trucks or buses or those kind of things, it's important that we essentially obtain a much higher value of force, but that can be only achieved within a with very small uh, vertical rise, because the force is much more larger, so the vertical rise would be inversely proportional to the distance. That's why this is the idea. So this is what is happening. Now you might wonder one thing, that well, if f2 simply does go up by a very small amount, what benefit are we going to get out of it? I mean, is there I mean, what is the practicality of this whole thing? I mean, why are we learning this anyway? Because this is not going up any by a very large amount. That can be a very logical question. We're going to answer this question just after a while, but for the time being, do any of you have any question up so far? Anyone? বলবান, তোমরা কি আমার কথা শুনতেছো?
Yes, sir.
Acha. Apparently there is no confusion, so we are moving on to this part. And then it says that then it says nothing else. So this whole thing is done. One of the things that is pretty interesting for the chapter of density pressure is how does a hydraulic jack works. We have a pretty interesting figure for the hydraulic jacks within your worksheet. So I'm gonna try to pull out that figure and give you some heads up from that question, and then maybe we're gonna try to look out for some simulation for uh, how does this thing work. Hey, I was talking about this one. This is what we call a hydraulic press. I'm going to explain the working of this hydraulic press so that you understand this thing well. And we're gonna because if you understand how this whole thing works, you're gonna have a pretty good idea for why this whole hydraulic system is good, or why is it beneficial for us. Because up till now it was not very much beneficial. You push it by a whole amount down, this one practically doesn't go up by very much. So maybe a total change of 1 meter on the cylinder might give you only, let's say, a couple of centimeters over here, depending upon the ratio of the cross section area. So if you the bigger force you want to get, the smaller height you are going to get in the same opposite ratio. So let's have a look over here and try to understand what this figure is actually working for us. I'm gonna increase the size of this thing a little bit. Actually, can I increase the size of this thing? I cannot. So let's just বলো বাবা।
একটা সাইজ বাড়াতে চাচ্ছেন? হ্যাঁ ঠিক আছে, কোন দিক দিয়ে করা যায়?
বসা ফেলার পরে করা যায়, কিন্তু ঘোরানো
না
যায় না।
স্যার, ওই যে কোনাতে যে স্যার ওই যে ইনক্রিজ রোটেট করেন না আপনি,
হ্যাঁ হ্যাঁ হ্যাঁ,
ওটা জাস্ট সামনে পিছন করলেই হয়।
বিউটিফুল, থ্যাংক ইউ very much. That was very helpful information. Oops. Okay. ঠিক আছে, আমি এটাকে এখানে নিব এবং আমি পুরো জিনিসটাকে বড় করতেছি। 100% দিলে কতটুকু হবে? আচ্ছা, 100% তো অনেক বড় হয়ে গেছে। আচ্ছা ঠিক আছে, এখন আমরা দেখি। Everyone, try to understand the working of this whole thing. This is not an animation, this is a very simple fixed figure. So there are certain stuff that you would have to visualize. I might actually find a simulation on the YouTube and actually show you while not recording the thing because of copyright issues and stuff. But I'm going to explain the working of this whole thing step by step. And if you have confusion at any part of the discussion, please let me know. Raise your hand, just ask a question, no problem. This is our smaller piston. This is our larger piston. You can see that piston P has an area of 20 centimeters square only. Our piston Q has an area of 400 centimeters square. You have to understand this figure is not drawn to scale. By no means this figure is drawn to scale. And over here we have an oil reservoir where we only have atmospheric pressure, so we don't have actually much to pressure over here. And there is a connecting tube between the two cylinders. And at the bottom we have a full connecting rod that is going from the second cylinder or piston cylinder Q all the way up to the reservoir once again. What we're gonna do to lift up this piston Q by a significant amount of time, we're going to move this X handle. We're going to move this end of the whole rod up and down. We're going to move it up and down. So one of the things that you need to understand that whenever we will be moving up and down, we are going to have some mechanical advantage because of lever, because this is a type 2 lever. So what I'm trying to mean is that, have a look over here. Here, whenever we're going to push this down, by Newton's third law, this piston P will be pushing the whole thing up, because if you're trying to push it down, the liquid is not going to want to move on their own by their own virtue. We have to push them to go out of the cylinder. So we're going to have two opposing forces working in this scenario. So one force is this application downward force, and the other force is the application of upward force. And and if we are moving this at a constant rate, let's say you're pulling it down at a constant rate, you do see that this is a pivot point. So this force F, let's say I'm going to name it as Fx, and let's say this force is Fp. The product of these two forces, I mean, you have to understand, kids, that Fp is, in this case, I'm representing the Fp as the force that the piston experiences from the oil, or let's say this is the Fp force. By and the force exists because the piston is actually pushing the oil down. So piston is pushing the oil down, and by Newton's third law, oil is trying to push the piston upwards. By Newton's third law, they both have the same value and perfectly opposite direction. So by this Fp force labeling, I'm essentially trying to mean the force that the piston is experiencing from the oil. এই পার্টটা কি বুঝা যাচ্ছে? This is not the force that the piston is creating on the oil. This is rather the reaction force that the oil is applying on the piston. বলবান বুঝছো কিনা দেখো? I think so. আচ্ছা, কোশ্চেন থাকলে বলে আমাকে। সো এখানে জিনিসটা হবে যে আমাদের এই ফোর্স থেকে আমাদের এই পিভট পর্যন্ত টোটাল পারপেন্ডিকুলার ডিসটেন্স হচ্ছে এই পুরাটা। All of this thing is the total perpendicular distance. So let's write this as dx, and this is the perpendicular distance for dp. So you can see over here very well that whenever this piston, this handle is going to be moved at constant speed, let's say someone is pulling it down at a constant speed, then there is a equilibrium of moment, which means fx dx should be equals to fp dp. The moment should be exactly equal on both sides. And if we now subject fp out of it, you can see that this is going to give us fx into dp by dx. দেখো এই কোশ্চেনটা বুঝা যাচ্ছে কিনা? This in the first place gives us a huge mechanical advantage, which means if this handle is really far away from the piston, you can actually push a very soft amount of force to get a significantly large force over here. So this equation, the moment equation over here, is giving us some mechanical advantage. This is what we call the mechanical advantage. Mechanical advantage means that something by which you can increase the force. You can never do more work than you can never achieve more work or gain more work than you are actually putting in. The work is always going to be a constant amount, or energy is always going to be a constant amount, but you can always increase the force. That's the reason we have such a long arm. So let's say we are now pushing this down. So try to understand, consider all of these valves are in their original position, and now currently we are pushing the piston downwards. Let me draw that with blue. So whenever we will push the piston down, what's going to happen? This whole piston, this whole cylinder, or this oil in the cylinder, is going to experience a high pressure, and it's going to try to expand outwards because of the high pressure. Now you can see over here we have two valves over here. This is a valve, this is a valve. The way these valves are designed is that both of these valves are only going to open on the right, which means if they are pushed from here or if they're pushed from here, only in this case they are going to be open. If they're pushed from the other side, they're going to get closed. They're going to get stuck on the position, and then they're not going to let anything to the left side. So both of these valves are open to the right, and they're going to be only allow fluid flow or liquid flow or oil flow from the left to the right. If anything is trying to go from right to left, the whole thing is going to simply become what? What? Can
It's
someone
gonna
tell me?
close.
The valve will close.
The valve will close. So if any times the force is applied from the right to the left, the valve will essentially close. So this is the purpose of the valve. Valve basically allows fluid flow in one single direction. So whenever this handle will be pushed down, there'll be high pressure over here. This high pressure is going to work on the valve. This is going to work on the cylinder area. This is going to work everywhere equally. This is going to work on the outer periphery, so inside periphery of the tube. So everything is going to be under high pressure. And because this valve is closed, this oil cannot actually go back to the reservoir. It has to move through this tube, and then this oil will apply pressure onto this valve from the left. So that force from the left will open up this valve, and as long as for the duration that we are going to be pushing this X force down, this valve is going to remain open, and some amount of this valve will be open, and oil will enter into the cylinder Q through that tube and eventually go from left to right. That's the operation whenever we are pushing it down. What happens when we are pulling it up? I'm going to show that with green. If you're pushing this object upwards, then we're going to be lifting up this whole thing in the upward direction. Lifting up this whole thing in the upward direction is going to attempt to produce a partial vacuum. বুঝা গেছে? Hello.
Yes, sir.
So whenever we lift this whole thing up, this piston is going to try to go up, which means within this piston we're going to have a bit of negative pressure. Negative pressure means it's going to be experience a smaller pressure because it is trying to produce a void over here. So whenever there is a negative pressure, it means the pressure from the outside to the inside is going to be more. So this is going to try this lifting up upwards is going to try to produce a void over here or empty space over here, which the hydraulic system would not appreciate. So liquid from either side, both sides are going to try to come and fill up that possible void or try to rebalance the pressure. But you can see that whenever this is being lifted up, this valve is going to experience a pressure in this way from left to right, whereas this valve is going to experience a pressure from right to left. So now in this case, this valve is going to become closed and this valve will open, and some oil from the reservoir is going to flow into the smaller cylinder like this. So that's for the upward. বুঝা যাচ্ছে? এই পর্যন্ত বুঝা গেছে কিনা?
Yes, sir.
Okay. So এখন জিনিসটা হবে যে whenever we are lifting it down, all is going in from left to right, and whenever we are lifting up, all is entering this cylinder. So if we keep on doing this motion, up down up down up down up down, we will basically transferring oil from the reservoir into the cylinder P, and then from the cylinder P into the cylinder Q. So the amount of oil within this part is going to slowly start to increase and increase and increase. And this is essentially how we're going to be able to lift up this piston, which is represented as piston Q. Now, what is important for you to understand that that as we keep moving this up and down, the level of oil in the reservoir is going to become slowly less and less and less, and more oil is going to be on this part. So the whole of this piston connected whole platform is going to start go upwards. That will enable us to achieve a very large amount of force over here. So this is basically how it works. So within a hydraulic system that we use for a car, which is a red type of cylindrical object, this is the very basic thing or the basic fluid flow diagram. But whenever we manufacture the whole thing, we essentially can have a lot of different designs. That really doesn't matter. What I want you to understand that by moving this handle up and down repeatedly, we can continuously transfer oil from the atmospheric pressure reservoir on the left, and then we can move it to this part, and then we could move it to this part. So this is perfectly all right. And as a result, the level of this water is going to slowly go down. Let's say we are lifting at this object to lift up some heavy object. We could also do this to squeeze some crops to get the juice out of them. Could be mustard, could be sugar cane, could be anything else, whatever. So for purposes, or we could also use this whole mechanism to lift up a car or a bus if you want to change some tires or do some other stuffs. Doesn't matter. So you apply the load over here, and this is going to be able to lift up the load, and how much force benefit you're going to get is exclusively dependent upon the ratio of these two things. So this is going to go down. This level is going to slowly go down. This level is going to be pretty strict again. And whenever we are done using this whole load thing, so let's say whatever the purpose that for which we are using this larger piston, if you are done doing that, and now we want to bring the whole thing back to the original stage, and then we have to restart our whole cycle, that's exactly when this tap is opened. That's exactly when this tap is open. Whenever this tap is opened, liquid has a free way to flow by. So the part of the whole system which has a higher level of liquid, that is going to essentially come back here. And whenever we'll open this up, all that was accumulated within the cylinder Q is going to flow through this valve and eventually get back to the oil reservoir, and this thing is going to start going down, and this thing, the all over this reservoir is going to go up, and after a couple of seconds all the water will leave from this whole from this thing, and we can use it. এই পর্যন্ত বুঝে গেছে কিনা যে আমাদের সিভিল কর্পোরেশনটা কিভাবে রিপ্লেস করা হয়েছে? Any question? Pulaman?
No, sir.
আমি কি কোনো সিমুলেশন দেখাবো নাকি তোমরা একটু পরে কষ্ট করে নিজেরা দেখে নিবা? সিমুলেশন খুঁজতে গেলে আবার সময় লাগবে। তোমার এটা তোমাদের হোমওয়ার্ক দিলাম, তোমরা একটা ভালো একটা সিমুলেশন বা অ্যানিমেশন খুঁজে বের করবা যেটা এই হার্ডওয়্যার রিপ্লেসের ওয়ার্কিংটা বোঝা যায়। So if you understood how this whole thing worked, answering this whole question should not be as difficult as you might think otherwise. So what I would like to ask you at this current moment is to pull up this question in your worksheet. This was question number which one? Sorry, this is question number 12 on page number 105, and I want all of you to attempt this question right now. I'm going to give you some time for the attempting, and then I'm going to resume the class and I'm going to go for the solution as per your requirement. বুঝছো কত নাম্বার করতে বলছি? নাম্বার 12। এই পুরো কোশ্চেনটা এখন একটু ট্রাই করো। এখানে খেয়াল করো আমাদের নাম্বার বিটা হচ্ছে বিআরসিটা হচ্ছে কি? বিআরসিটা হচ্ছে আমাদের mathematical questions. Sorry, A is a how pushing as cause okay. BSc are the mathematical questions, but A and D and also E, all of these three things are descriptive questions, which means in D we have 2 plus 1 3 and over here 5, so it's 2 plus 1 4 and 5 19. So তোমরা এই কোশ্চেনটা ট্রাই করো সবাই। I'll give you some time. I'm pausing the recording. So we're now discussing A for to determine how much are we supposed to write for a question that has 5 marks in it. The question says that a force is applied downwards at X as shown. Piston Q rises in the slave cylinder. So we have the input given and here the final output given. There the piston P is exit to numerical values provided. In A question it says explain in detail how pushing X downwards causes piston Q to rise. State clearly what happens to valve A and valve B. So we simply have to consider what happens in sequence as this handle X is pushed down. So try to understand, this is how I would write. Handle X pushed downwards. I'm going to give a right directional arrow, something like this, right arrow. Piston P goes down, produces high pressure. Valve A gets closed because it is being pushed to the left by the liquid, or is they say oil? They don't say oil. So because valve A becomes closed because the oil pushes the valve A to the left. The oil moves through the tube into piston into the slave cylinder, and when valve B is pushed to the right, it opens. As the volume of oil in slave cylinder increases, that pushes the piston Q upwards. This is what I'm going to say, because they have said explain in detail, so which means I have to give reasons why this is happening. So I said as it is pushed down, there is a high pressure over here. That high pressure is exerting on the valve A on the left, so the valve A is closed, remains closed, and because of the high pressure, oil is going to move out through this tube and apply a force onto valve B to the right, which opens the valve B. That's the reason that the force is applied towards right, and the valve is open, and then oil is going to enter into the slave cylinder. As the volume of the oil in the slave cylinder increases, piston Q is pushed upwards. These are the steps that I would write, but I'm not sure about the mark scheme, so we might as well look at the mark scheme to find out what the examiners are looking for you, especially in the examiner's report as well. So let's have a look at that thing. This is the examiner's report. This was question number what? This was question number 12 of the density pressure chapter, very last one. So let's just jump here. This is the composite density pressure number 12. There we are. So for number 12, we don't have a mark scheme, so we only have the examiners report. So let's try to make the best out of it. Have a look. The examiners were disappointed by the level of understanding shown regarding hydraulic systems. In A, only simple explanations were required, such as the piston P causes a pressure in the oil which acts on piston Q and creates a force on that piston. In the process, oil moves to the slave cylinder, keeping valve B open and valve A shut. So these are the amount of information you are asked. You are expected to write. Read again. Have a look again. The examiners are disappointed by the level of understanding shown regarding hydraulic system. So in general, most of the students didn't know how this whole thing works, which is not for you because you already know how it works. I explained it. In A, only simple explanations are required, such that এই ডাটার পরের থেকে এই যে such ডাটার পরের থেকে যেটা শুরু হচ্ছে এটা হচ্ছে তোমার মার্ক স্কিম. You're going to start writing directly from here. Piston P causes a pressure in the oil which acts on piston Q. It creates a force on that piston. In the process, oil moves to slave cylinder, keeping valve B open and valve B A shut. If you write only exclusively these full sentences, you're going to get full marks. To be more precise, I also included the force applied on left or right so that it is more clearly explained for the examiners. Does it answer your question? Asif and Nuran?
Yes, sir.
Yeah. So that's that. And always, I mean, whenever you're trying to write an explanatory question, I personally feel that writing with arrows is a much better way than preferably to write in sentences, full sentences, that this happens, full stop, then this happens, then because of this happens. You just write a phrase and then write the consequent thing and then give an arrow and write the consequent thing. Write in phrases. You don't have to write full sentences. In the mark scheme, you always see that no mark scheme have full sentences in them. They have phrases for which you'll be marked. So if you can practice and adopt the thinking level and the delivery level to that understanding point that you can actually write in phrases, it actually saves time. Your answers will be precise and the examiners will be pleased knowing that you know what you're doing, and they will also understand that you actually did study the mark schemes and the examiners report pretty well, which makes a really good impression, like very highly rare, if you ask me. So if we have a look for the other question over here, B আর C আর D পারা গেছে আমাদের এই পর্যন্ত. And number E as well. We can actually look for the entire mark scheme because not much is left. Have a look. Part B allowed candidates to apply the formula for pressure in 2 they state the pressure in the slave cylinder is the same as the master cylinder. So stating that thing would actually holds a mark, stating that the pressure would be both equal on both the cylinders. The formula for pressure was generally well known. For candidates who are able to use even an incorrect value for the pressure in 2 to earn full marks in number 3. So because the reason they are saying that, because in number 3 question, calculate the force exerted by the oil in on piston Q. So I believe calculate the pressure in by the piston ball P. Here we have 2 marks. Calculate the pressure in the slave cylinder. This is 1 mark, and calculate the force exerted by the oil on piston Q. This is also going to be full marks. What does this thing means? Candidates were able to use even an incorrect value for the pressure in number 2. Oh, acha. This is meaning that they entertain ECF. This simply means that they entertain ECF. That if you did calculate a wrong pressure value for your B1 and use that value to calculate the forces over here, and if this calculation was correct, you're gonna score full marks over here as well. So if your pressure formula is correct, which means pressure equals to force by area, and then you're gonna get this mark. And if এক মিনিট বলবান আসসালামু আলাইকুম, sorry, I had a call that I could not avoid. I would like to put it into silent mode. Yes, done. So it says that so that's what they're saying, that if 3 had an ECF in it, so if you miscalculate this value, you would still score full marks in number 3. That's okay. And then the question says that calculations number 3 calculations of the volume of oil in number C1 was a simple task by multiplying the area by the distance, but it was not always answered correctly. Most candidates realized that the valve A opens in D and valve B shuts, but it was common misconception that piston Q returns to its original position. Even though candidates realized that valve B was closed, many candidates appreciated the need for the fluid to be incompressible in E, although incorrect attempts frequently were related to density references. So I think that pretty much makes sense, that you have to say that air or gas is a compressible fluid, so the force would not be actually be applied on the piston Q, whereas being an incompressible fluid, which is a liquid, the force can be perfectly exerted on the piston Q. So that's basically the whole idea of this question. This is pretty good, a good question, because we have a lot of the descriptive questions over here, which actually checks your detail level understanding for how does the hydraulic system works. I like this question. It checks how much you know. Any questions so far? Confusion so far? Anyone? বুঝা গেছে কিনা এটা clearly? আচ্ছা, আমরা আচ্ছা, এখানে তোমাদেরকে আমি আরেকটা জিনিস বলি, আরেকটা সিম্পল জিনিস বলি, সেটা হচ্ছে যে আচ্ছা আমি এখানে একটা সিম্পল জিনিস দেখাই। এই যে এরপরে যে কোশ্চেনটা আছে, কোশ্চেন নাম্বার 13, question number 13 is also a question relevant to hydraulic systems. So what this question essentially shows you, that we have a small we have a certain syringe and air over here, which had initial volume of air of 60 centimeter cube. We have some tube connecting it with a rubber pipe. The entire air volume within this air pipe is 5,000 centimeter cube, and the question also says that this pipe is not going to undergo any expansion. So the total amount of air volume within this thing is going to be always 5,000 centimeter cube no matter what. This will not increase in volume, which means if we push down the syringe by a certain amount, the amount of volume decrease that this level will represent, this amount of air is basically going to be coming out over here and push it onto this manometer to make sure that there is a significant amount of volume differences. So the air can undergo compression because it's air, so you can have increased pressure, but the volume of this air volume will remain constant. Have a look. An engineer wishes to check the volume of air inside a pipe, and to check that the pipe is not leaking, he connects the syringe to one end of the pipe and a manometer to the other end, as shown in figure 10.1. The syringe initially contains 60 centimeters of air, and the pipe contains 5,000 centimeters of water. The volume of the narrow tubes may be neglected. So these narrow tubes, which are used as the connecting tubes, we are considering those volumes to be negligible, which means the total amount of air that we are working over here is 60 centimeter cube plus 5,000 centimeter cube, which means 5,060 centimeter cube is the total amount of air that we are starting with. Then it says that all the air is initially at atmospheric pressure 1.000 into 10⁵ Pascal. If you see over here, this is actually quite interesting. They have given up to 3 decimal places 0.000, which means this is a 4SF number. Do you want to understand that this is a 4SF number, everyone? This 1.000 is actually a 4SF number. Do you understand that?
Yes, sir.
এই এসএফ নিয়ে কারো কোনো কনফিউশন থাকলে আমাকে বলো, বিকজ এসএফ এ কনফিউশন থাকলে পরে গিয়ে যেন পস্তাইতে হবে, and that confusion will linger up to you and cause you to lose mark all the way up to your A2 level at the least if you go to any university and eventually. So if you're not clear with decimal places and SF properly, you are going to suffer for that. So it's important that you don't do that. So then you see the piston is pushed fully down and held steady so that the total volume of air decreases. So we're going to push it all the way down. So there's going to be a new volume. So all the air that was initially the syringe is going to enter into this thing. But the question says that the pipe was not going to increase in volume, which means initial volume of the total air was 5,060 centimeter cube. New volume of the total air is going to be 5,060 centimeter cube. Now the question says, explain in terms of the molecules why the pressure of the air inside the pipe increases when the piston in the syringe is pushed down. Okay, this is a very interesting question. This question, question is somewhat related to the temperature, heat segment of our syllabus, where we have a chapter called gas laws, or actually gas laws is not the name of the chapter. Gas laws is a part of the chapter. The name of the chapter is, I think, fundamental theory of objects or something like that. Kinetic theory of objects. Kinetic theory of objects. Kinetic theory of objects means that basically is discussing how an object is built up and what kind of forces do they have, what kind of motion these particles can do. So basically the whole discussion of solid, liquid, gas, part of which I started to discuss at the beginning of today's class. So although you haven't learned about Boyle's law, at least not from me, so you would not know what is actually happening. But there are a couple of specific terms that we use whenever we go ahead to explain us the change of a certain gas. I'm gonna write those things up, And I'd like you to write those things right over here. Write in small fonts because you need to accommodate 3 different bullets. So I'm going to try to write this 100%. There is no way you can accommodate this whole thing over here. Okay, if you finish up over here, you can actually go down and start writing over here. I mean, you can use the space, and then when you are done writing the whole thing, then you can give a horizontal line and then start writing the answer. No big deal, because you would have ample space to finish up the answer anyway. You have 2 full pages, so that should be more than enough. So if you cannot accommodate it fully over here, just go down here and keep writing over here. Don't bother. আমার লেখা পড়তে পারতেছো?
Yes, sir. Project.
আচ্ছা, হ্যান্ডরাইটিং না বুঝলে জিজ্ঞেস করো, বাট ভুল লেখো না। লিখে নাও, লেখা হলে 2বার 3বার পড়ো পুরো জিনিসটা, তোমার হ্যান্ডরাইটিং এ পড়ো, বোর্ড থেকে পড়া লাগবে না, এবং পরে জিনিসটা বোঝার চেষ্টা করো, তারপর আমাকে কোশ্চেন করো, আমি বুঝাবো। The reason I'm circling and giving so many star marks around the word average is because once you would learn your whole syllabus and you'll be prepared for your O-levels exam, you would know what are the key phrases you have to use to explain the changes of these three properties for a certain amount of for a fixed amount of enclosed gas. Fixed amount of enclosed gas means the amount of gas or the mole number of gas or the number of particles of the gas will not change, but they are physical variables of pressure, volume, or temperature. They are going to change. So which means we are not going to enter any new amount of gas within the whole closed system. We're not going to take away any gas out of it. So the amount of gas or the total number of all the molecules of the gas that will pretty much remain the same. That's what we mean by the term fixed amount of gas. So the reason I have highlighted the word average is because when you will be prepared for your O-levels exam, you would know what are the phrases by which you should talk about the changes of these three physical variables: pressure, volume, and temperature. For most students, for most veteran students, even when they who are very good at physics and they know the subject inside out almost for the all of the syllabus, they've practiced a lot. In most cases, they lose mark in these questions not to remember to write the word average. This is the word that costs them 1 mark every time for most of them who lose the mark in this 11 question. The word average in this case is a very important thing because we're not talking about the intermolecular space between exclusively two particles. We're talking about the average intermolecular space of all the particles, which means if all the molecules were equidistant from each other and standing in a fixed position, what would be the average distance between them? That's what we mean by average intermolecular distance. Similarly, temperature is also defined by the average kinetic energy of the gas particles. You have to understand. Did you guys come across the term Brownian motion in your chemistry? Brownian motion. Anyone?
Yes, sir.
Yes.
Okay. For those of you who haven't, you will eventually. The way idea of Brownian motion is that the random haphazard movement of fluid particles within its own body is defined as Brownian motion. Robert Brown, he first discovered this effect, and after his name, it was named Brownian motion. So you have to understand that at any instant of time, not duration, at any instant of time, all the gas particles velocity is not the same. Some particles are moving at really high speed, some particles are pretty slow, but the average kinetic energy of all the particles would always remain the same if the temperature is kept constant. You cannot say how much is the kinetic energy for one single molecule, because one single molecule doesn't make up the whole gas. It is made up of all the molecules which are involved inside this thing. So essentially, it is the average kinetic energy of all the gas molecules that defines the temperature of the object. And in the last line I have written, for all three, more, less, less. What this means is that any of those explanatory phrases goes higher, you will have higher of that variable, which means if you have increased rate of collision between the gas molecules among themselves and the container wall, your pressure will increase, and vice versa. If you have increase in average intermolecular distance, your volume of the gas will increase. If you have increased average kinetic energy of the gas molecules or gas particles, your temperature will increase. Do you guys understand that why am I using the term particles and not molecules or atoms? Did I tell you this ever? I mean, why the fascination for particles? Why not molecules or why not atoms? লিখে নাও। লিখে হচ্ছে সবার? I think that's enough time to complete the writing. So I'll move on to the next part. So let's have a look at this question. Although it's 7:30 and I understand you guys have to go, so I'm gonna go through the question uh, and let's have a look. So in this question, it was explain in terms of molecules why the pressure of the air inside the pipe increases when the piston of the syringe is pushed down. Now, one thing is obvious: when the piston on the syringe is pushed down, obviously the total amount of air that was kept together, including the syringe and the pipe, the total amount of air underwent some volume decrease. That's visibly clear. But you cannot say that the volume decreased, that's why the pressure increased. You cannot say that because it's explained in terms of molecules. They have said expressed in terms of molecules, which means in this case you have to say when the because after pressing the syringe down, comma, the average rate of collision between the gas molecules, between the air molecules remaining within the pipe increases. That's the word. Then it says in this section, assume the pipe does not leak and the temperature of the air inside remains constant. So all of these calculations are based upon Boyle's law. At least two of them are. So for the time being, if you can and if you do have a good understanding about Boyle's law, you learned it in your school or somewhere else, you can actually attempt this question. But for the time being, I'm not solving this question. Once we finish our heat chapter, I might as well get back over here. But I'm quite sure that once we finish our heat chapter, you would be able to solve this problem just like that. So let's forget about that. I really want to get to number C. Number C, have a look. C1 says, if the pipe leaks very slowly, state what happens to the levels of water on each side of the manometer when the piston is pushed down and left down. Draw a diagram of the manometer to illustrate an answer. So have a look. If pipe leaks very slowly, which means the pipe that is, if it is leaking out slowly, because you have to understand, initially the total pressure of the syringe and the air was 1 atmospheric pressure. When we push the syringe down, air from the syringe enter into the pipe and that increases the pressure, which means currently when the syringe is pushed down and held in this position, currently the pressure inside the pipe is higher than atmospheric pressure. This will cause the air that is trapped within this tube to attempt to escape out of this system so that the pressure between the inside and the outside can be balanced. So air trapped within the tube will have a natural tendency to leak out. That's why they are saying that if the pipe leaks very slowly, and that very slowly is very important, it's not going to happen pretty fast. It is going to take significant amount of time, let's say maybe hours, maybe days to achieve that equilibrium pressure, so that enough amount of molecules leak out from the tube. So that's very slowly is also very important term. If the pipe leaks very slowly, state what happens to the levels on the water on each side of the manometer when the piston is pushed down and left down. Have a look. This is a manometer. Whenever we're going to push this thing down, the pressure on this thing is going to increase. So if as the pressure of this whole thing is going to increase, what will happen to the level of these two manometers? Which side will go down and which side will go up? Which side will go down? You tell me. Over here, the pressure increased. So which of these two sides will go down?
The left side.
The left side. High pressure side always goes down. So this side is going to go down and this is going to go up by the same amount. This is going to happen as long as the pressure over here is higher than the atmospheric pressure. Now try to visualize. Let's say this pipe is slowly leaking out air, which means the pressure over here is slowly becoming less and less and less, which means this gap, which was representing this gap, let's say, let me copy this up. I mean, so let's say when the gas is leaking out, the moment we push this syringe down, this level is going to go significantly down and this level is going to go significantly up. Let's say currently this is our height difference, and this height difference of between two level delta H is represent the delta P, which is can be given, so delta P represents the delta P, which can be given as delta P delta H rho G. This is the equation for the pressure difference. You have seen this in the earlier class in the manometer discussion. Now, if the pipe is slowly leaking out, which means this is leaking out and the pressure is dropping, which means delta P is going to be slowly become smaller, and delta H will also become smaller, which means the left side is going to slowly rise up and the right side is going to slowly come down. And eventually, when the pressure has become equal across the inside the tube and outside the tube, the levels will once again come to the same position as shown in this figure. So figure আমাদের ইকুইলিব্রিয়াম কেসে যেরকম দুইটা লেভেল ইকুয়াল দেখানো আছে, যখন দুইটা লেভেল টিউবের ভিতরে প্রেসার এবং বাইরের প্রেসার মিলে যাবে, তখন আবার আমরা এই জিনিসটা পাবো। But this will take significantly long amount of time for to happen because the question said that the pipe is leaking very slowly. বুঝে গেছে? প্রমাণ। আচ্ছা, C2টা আমি চাচ্ছি তোমরা নিজেরা ট্রাই করো। C2 class solution আমি এখনই বলতেছি না, তোমরা নিজেরা ট্রাই করো, get some idea, think about some possible points that you would like to write about it, and justify those points within your head by using physics ideas and equations and whatever, and then have a look at the mark scheme and the examination report to check whether your guess was correct or not. And we're going to start our next class from this thing. And on our next Friday class, I plan to discuss some additional timing replacing the Friday class, because the thing is, I currently do not have any weekly day that is entirely off. My wife and kid is here, and I have to become a family person, and I have to have at least one day that is entirely for my family. So I don't know. It doesn't essentially have to be Friday, but Friday is one of those days. And I actually have a lot of openings currently, because yeah, we have started the mock proceedings for our O levels kids and the A2 kids. So we can actually discuss a lot of free times available. So in next class, we're going to discuss some timing change for the Friday class. But the Friday class will happen in that time. We're going to propose and discuss some timing change for the upcoming Friday classes, not the very next one. Do you get my point? বুঝছো কি বলছি?
Yes, sir.
আচ্ছা, আজকে এই পর্যন্ত থাক। থ্যাংক ইউ ভেরি মাচ ফর দ্য কোঅপারেশন। আমি একটু পরে লেকচার আপলোড করে দিচ্ছি, তোমরা এই ওয়ার্কশিটে পুরোটা অ্যাটেন্ড করবা, এটুকু তোমাদের হোমওয়ার্ক থাকলো, এবং নেক্সট ক্লাসে কোনো প্রবলেম থাকলে আমাকে বলবা। আল্লাহ হাফেজ।